Hi Year 5, this is today's video and today we're going to be concentrating on prime numbers. We're going to revisit a little bit of yesterday's vocabulary, thinking about those factors and multiples, but we're going to investigate the idea of prime numbers a little bit more today, which we did introduce yesterday. So hopefully you got on well with that yesterday. If you didn't and you're struggling a little bit, don't forget just to let me know and I can give you a bit more help with that. Now, before I get into it too much, I'm just going to go through yesterday's challenge. I hope some of you had a go. So the first one was, Nancy is double her sister's age. They are both older than 20, but younger than 50. They are both multiples of 7, so that means they're both in the 7 times table. How old are they? So the first thing that I thought is that, well, I know that they are between 20, so because they can't be younger than that, and then younger than 50. That's quite a big range. Key information, Nancy is double her sister's age. So we know that the oldest that Nancy could be is 25, because if we double 25, then we get to 50. She can't be older than that. So the next bit of information, they are both multiples of 7. So I had to think about what are the multiples of 7 between 20 and 25. Hopefully you came up with 21, the only multiple of 7 between that range. Okay, but then Nancy isn't 21, it's her sister who's 21. So Nancy is double her sister's age. So if we double 21, that gives us 42. Also a multiple of 7, and so Nancy must be 42, and her sister is 21. Hopefully you got that. Now, the second challenge was about Bob. Bob's age is a multiple of 7, so again, but it's also 3 less than a multiple of 8. How old is Bob? So the first thing that I did for this was list my multiples of 7, or my 7 times table. So hopefully you're keeping on top of your 7 times tables, or all your times tables. Just going to go to there. And then I also listed my 8 times table so that I could see what the difference was. Okay. Now, I did do it further than this when I was first working it out, but this is where I started. So I've got my multiples of 8 on my 8 times table and my multiples of 7. I then had to come back to the question. So Bob's age is a multiple of 7, so I know it's got to be one of these, but it's also 3 less than one of these, a multiple of 8. So straight away here, I can see that if Bob was 21, that would match because that's my multiple of 7, and it's also 3 less than the multiple of 8, which is 24. And so therefore, Bob could be 21. Now there is some more possibilities to this, so see if you can find some more. I want them to be feasible, okay? So let's think about how old people live till. But good luck, let me know your answers. Okay, today's learning is a little bit more in-depth about prime numbers. So first of all, we need to refresh our memories. What is a prime number? A prime number is a number that only has 2 factors, 1 and itself. Okay, so yesterday we looked at what a factor was. So a factor is a number that we can times together in order to get our answer. Okay, so the prime number that I'm going to start off with is 5. It's a prime number because the only way that I can make 5 by doing a multiplication is 1 times 5, or one group of 5. One group of 5, or 5 groups of 1. We know that those are the same thing. Okay, so 5 lots of 1. That's the only way that I can make 5 by doing a multiplication. So if I did my factor book that we were doing yesterday, I know the only way I can do it is 1 times by 5. So that means that it must be a prime number. It only has 2 factors, 1 and the number itself. I mentioned yesterday that there was a special prime number. Now this special prime number is 2. I'm sure some of you will be shouting at your screens, 2 is a special prime number because it is the only even prime number. Okay, so the only even prime number. Now that means that all other prime numbers are odd. Okay, so this is because any other any other even number must have 2 as a factor. So it would have 1 itself and 2. So that means it cannot be a prime number. However, this does not mean that all odd numbers are prime. Okay, this is a trap that lots of us fall into. There are lots of odd numbers that are not prime numbers, so they have more than 2 factors. Now, the mathematical term for this is composite numbers. So your first task today is, I want you to pause the video and I want you to list the first 3 odd composite numbers. Okay, so I want the first 3, so starting from 1, which we know is a prime number, it's a bit of a funny number. I want you to find me the next odd number that isn't prime. Okay, and I want the first 3. Okay, so hopefully you've had a go at this already. So I'm looking for the first 3 composite numbers that are odd. Okay, so going through, so the first one that I can think of is 9. So it's the first number that is odd, that is not composite. That is composite. It has more than 2 factors. So I can do 1 times 9 and I can do 3 times 3. So it has more than 2 factors. The next odd composite number I can think of is 15. It has more than 2 factors, even though it is an odd number. 1, 15 and 5. Okay, so that makes it composite. And the next one, you have to go quite far along, is 21. It's another odd number, but it is not prime because it has factors 1, 21, 3 and 7. So because it's got 4 factors, it cannot be prime. Okay, now it's time for your next task today. So it's time to pause the video. I have written 3 numbers on the board. We've got 17, 27 and 45. Your task is to tell me which of these are prime numbers. And the really important part is for you to tell me why. Why is it a prime number or why is it a composite number? Okay, we'll go through it in a moment, but I want you to have a go first. Good luck. Okay, hopefully you came up with the same answer as me. The only prime number here is 17. So that's because it's only got 2 factors. Only 2 numbers times together in order to get 17. 1 times 17. 27 is a composite number, so it has more than 2 factors. We can do 1 times 27, or we can do 3 times by 9. 45 is also a composite number. Wonder if you can tell me why. A big clue is the fact that it ends in a 5. So straight away, we know that 5 must be a factor of 45. So we've got 1, 45, 5, and 9. Okay, so hopefully we've got a good understanding of what is a prime number and what is a composite number. The next part to today is about prime factorization. Now this is just a mathematical term for something that we've done a few times, which is making a factor true. Okay, so we want to write a number as a product of its prime numbers. So we're going to reduce that number down until we get to prime numbers. So if we start with 42 and draw a factor tree, okay, so this is just called prime factorization. So I need 2 numbers that times together, remember that's important, it's not add, 2 numbers that times together in order to get 42. So the first ones that jump into my head is 6 and 7. Now I'm going to circle 7, hopefully you'll be able to tell me why. It's a prime number, okay? Next, I go to 6. 2 numbers that times together in order to get 6. Remember, it is times together, not add. So I know that 3 times by 2 gives me 6. Then, again, I know 2 is a prime number, it's our special prime number because it's the only odd one, and 3 is a prime number. So I have reduced 42 down as a product of prime numbers. So I would write that down as 7 times by 2 times by 3, and that will give me 42. So I've got a bigger number this time. I want to know the prime factorisation of 120. So 2 numbers that times together to get to 120. When it gets to the bigger numbers, you need to be thinking about what do you know already about this number. So you might be recognising the 12. So you might be thinking 3 times 4, how can I make that fit to 120? So we could do 30 times by 4, 40 times by 3. Or, again, if it's an even number, which if you're doing this, there will be lots of even numbers, we know that 2 is always going to be a factor. So we can think about, well, 2 times by what gives me 120. I know that 2 times 6 is 12, so 2 times, let's make it 10 times bigger, 60 is 120. Now, remember, circling my prime numbers. I know that 2 is a prime number. Then I go to my other number, so I've got 60. 2 numbers that times together to get 60. Let's start off easy, so I've got 10 and 6. They're both composite numbers, so I need to go again. So to get to 10, I can do 5 times by 2. And to get 6, I can do 3 times by 2. Then, thinking about prime numbers, 5 is a prime number, 2 is a prime number, 3 and 2, they are all prime numbers. So the prime factorisation of 120 is, let's put them together, 2 times 5 times 2 times 3 times 2. Now if you're feeling super good this morning, then we can condense those so they're a little bit easier to organise. So I know that 2 times 2, a number times by itself is a squared number, but I've actually got it 3 times. So 2 times 2 times 2, and the rest of it, I can put this together because I know that is 2 cubed times by 3 times by 5. And that is what we call the prime factorisation, or the product of prime numbers. Okay, again, something we've all done before. Okay, that concludes today's video. You are going to find today's tasks on Purple Mash today, primes, multiples and factors. So it's revisiting some of the things that we did yesterday and going a little bit more into detail with those prime factorisation. Some of you, I have also set you a bit of a challenge to do another task on Mymaths as well. So if you haven't got that, then don't worry, you can do plenty of practice. But if you have, then there's some extra things there to challenge your brains. That's it from me today. Remember, stay home, stay healthy.